Hello everyone, my name is Jatin Terde. I am a computer science engineering student at Vishwaniketan College of Engineering, which is in Khalapur, India. I am here to present IDLi, or the Indian Data Library. This is a project that I have been working on with ASAR, or the Association for Socially Applicable Research. It is a non-profit organization based in India that focuses on social problem solving through research, advocacy, and activism. The Indian Data Library is an ambitious project in which we are building a single point data access platform in India that aggregates data from multiple sources, for example, health and socioeconomic data, and makes it readily accessible for researchers and policymakers. I would like to initiate my presentation talking about the need for IDLi, which would be continued by the four major components of IDLi, which are the data inventory, search mechanism, query engine, and the search interface. Then I would give a comparison of IDLi with other similar libraries, talk about the challenges we faced, and end with the conclusion and further directions. So the need for IDLi. LMICs, or low and middle income countries like India, face abundant issue in data collection, data management, and usage. While the majority of the data recorded by the government is void of copyright issues, it is not easily accessible due to some reasons that we will get into. The data collected by private investigators may be more accessible, but has other issues like the copyright issues, lack of analyzable data, and significant time and resources to put the data in usable format. Data is not easily found. Most of the data is available in PDFs and JPEGs, which makes it very difficult to extract. This means when a person wants some particular data, he needs to invest a lot of time to find the exact data he requires. We find a need for an interface which is based on the fair, findable, accessible, interoperable, and reusable data guiding principle for data management. Here, interoperability is the characteristic of a system to work with other systems. To better elaborate what I have said, I would like to give a real life example wherein a researcher or policymaker needs data on malaria deaths. He goes to the NHP website and gets the data he wants. But as the data is available in PDF, he needs to find out for the variable he is searching for. Then he gets to know that the particular variable he has found cannot be, the data cannot be copied directly. So he needs to manually extract down the data, and which would take him hours. And then he needs to know that the correctness of the data, organize the data, and once everything is done, he can use it for his analysis. So here, although being from the medical field, the student had to perform a lot of tedious formatting as a basic step to get the required data right. On the other hand, the student visits the IDLi website, look up for the variable of his interest, or the person looks up for the variable of his interest and say malaria, and using the metadata variables, he and the time range he sets, a pipeline is run, and now he can easily copy or take the data sets from CSV formats and then use it for his research directly. So the data inventory. IDLi currently houses over 50 datasets. There are about 2,000 health and socioeconomic variables collected at individual, household, village, sub-district, district, and state levels between 1981 to 2021. The data is extracted and regularly updated from various sources and then wrangled into machine understandable formats along with the metadata to store in a database system. So these are all the data sources we have extracted the data from. These data sources can be segregated into two divisions. The first one is the survey datasets. IDLi currently houses 5 different survey datasets. And the next one is the registry datasets. IDLi has 4 different registry datasets, which include NHP, RHS, NCRB, and HMIS. So we have used multiple mixes of manual and machine-based approaches to clean the data and store them properly with their metadata tables. So herein we can think of a metadata as the index for the dataset. So the snapshot which is visible on the screen is actually the HMIS metadata snapshot, wherein we can see how we have used different types of specifications to as column names to store in the data. So this makes the content more finding. The search mechanism. The search mechanism is something what happens in the back of the IDLi to give the required results. So it can be divided into 2 blocks. The first one is the pre-processing block, and second one is the on-query block. In the pre-processing part, the dataset descriptions which are stored in IDLi are vectorized, and the vector representations are stored. On the query part, we receive an input query We receive an input query, and the input query is vectorized. So now we have two vector representations. One is of the input query, and the one is of the vector representation store. We find out the similarity and compare the similarity and throw the matched as results. The query engine. Internally, the query engine uses a standard interface to specify the exact data processing steps. The query builder web interface builds pipelines as per the specifications that the query engine recognizes. Thus, the pipeline can be stored for further use or templatized. The query engine translates the message into database queries that each backend recognize. Apart from the standard SQL queries, we also have a support for predefined functions in supported programming languages. We currently have the support for Python. The engine processes the pipeline steps and returns the results. Next, this is how the IDLi search interface would look like. The main features or the highlights would be the templatization and searching with respect to tag based, duration based, and place based systems. So the results would be available, and the user can simply click on the respective sheets and copy the data he wants. So comparing IDLi with other similar websites, we came across three very good similar libraries. One was SEDA, the other one was the health heat map, and the third one was the Indian data portal. So what does IDLi bring to the table, or what is unique is that sampling based ad hoc aggregations are supported by IDLi. For example, if the portal has a pre-calculated value of counts of surgeries across geographies, and an end user is interested in surgical rates with standard errors, so he can specify the calculations as surgical counts divided by population, and then he gets the results. This would apply to all the variables available from the surveys. The next thing is IDLi supports natural language based search. So this means that if you search for anemia, IDLi not only shows you documents which mention anemia, but will also show you documents which mention low hemoglobin. The third very main feature is that cross dataset aggregation, which means that if I search for anemia, I find it not only in the HMAS data, but also in national health profile data. And now I can get both the results in a single table by matching the geographies. Okay, the challenges. Wrangling data from heterogeneous data sources is time consuming. For the database we have so far, data preparation has been a huge task, which took us months and months of tedious work at ASAR. Limited capacity for data storage for non-profits in LMICs. The major issue that we face is finding a large storage system with good functionality, which is also affordable. So next one is human and machine errors, which were pretty common while data cleaning and format conversion, which means we had a need for constant verification and checks to maintain the correctness. Significant trial and error in selecting the appropriate algorithm was necessary because we needed an accurate, a good algorithm for the search mechanism part. In conclusion, I would like to say IDLi being cloud hosted allows easy access to data. We aim to add more data sets in coming time. We also plan to add a section for visualization of the data. So the next IDLi consists of a query builder with drag and drop option, which would be of easy support for searching things easily. Our templatization and search engine makes the data easily findable, accessible, interoperable, and reusable. The framework can be adopted to improve data democracy through adhering the fair data principles. We are planning to add more data sets in coming future. Next, we know the need to access data governance and ethics. And lastly, we need to continuously improve the natural language search part, because as in the search thing will increase or be improved, we could develop the system to be more better. So while thanking you, I would like to say that IDLi provides complex functionality and vast data at the tip of your fingers with a simple interface. We hope that this will go along a long way in building a data democracy in India and will scale up to our vision for it. So thank you for your time and patience. We hope to collaborate with some of you in your future.